Most people use Laravel in the user land. We use Laravel as our framework, but we don't really dig into the internals. And I know that the internals can feel very intimidating. The internals of any framework, really, any library, whether it is Laravel, whether it's Symfony, Rails, it feels a little bit intimidating to say, hey, I'm going to work through the framework's code. This thing that I use every day that's made by very smart people. I'm going to touch this. It's a little bit intimidating. At least that's how I felt in the past. So with this video, I want to show you guys a little bit how the Laravel core is structured, how releases are handled, how the code is organized, and if you wanted to either contribute to it or just learn how things work internally, where should you go to? So let's jump into the code and check it out a little bit. All right, so before we actually check the code, let's look at the GitHub organization. This is the Laravel organization, and we have two very important libraries. We have the Laravel framework, and we also have the Laravel repository. What we usually use is Laravel. That's the application side of Laravel. Whenever we clone the framework or we start a new project, we are basically cloning this repo. So this repo doesn't actually contain any core functionality. It just orchestrates it. And if we go to composer.json, we can see that it requires Laravel framework. We're not going to go in depth into how requests are handled, but if you want to look at that a little bit, go into public and then index.php. And you can see that the Illuminate package is the Laravel core. So we are importing the kernel and the request classes. And then we are instantiating the kernel using the container. We're bootstrapping the application. We instantiate the kernel, and then we handle a request. Well, what we want to look at is actually the Laravel framework repository, and that's the core functionality. The way that this repository is handled is we have multiple branches at all times. So for example, right now, the stable version of Laravel is Laravel 10. So we have a 10.x branch. However, we also have to maintain 9 for security patches, etc. So we also have the 9.x branch. And you can see that we had a recent commit on October 3rd. And right now it's November 16th. So a little bit over a month ago. Let's go back into 10. So 10 is the active branch. You can see it's the default branch. So if you want to contribute with a functionality that does not break any contract and does not have any breaking changes, it can go into 10.x. For example, those super requests can go into Laravel 10. However, if you want to contribute with something that is a breaking change or there's a change in a contract, you have to target the next release. And in that case, right now, it's 11.x. If you want to target the next release, you want to target the master branch. So although the 10.x branch is the active one, we also have master, which refers to the next release. As you can see, it is over 100 commits ahead of 10.x. By the time the Laravel 11 is released, Taylor is going to, or someone from the Laravel team is going to create an 11.x branch out of master, make that the default, and master is going to refer to Laravel 12. Now let's jump into the code. Well, the first piece of the code I want to talk about is how it is organized. Laravel follows a modularized architecture, I would say. Each piece of Laravel is a component and it is independent. You don't have, well, you do depend on a few core components. You're able to import a specific component from Laravel. For example, let's say that you want to use the Laravel query builder. You can import Laravel database and use that in your application. We usually use Laravel in the context of a full stack framework, but you can pull individual pieces of the framework and use in your application if it doesn't use Laravel. Or if you're using the Laravel framework, you can also disable certain modules of the framework. Let's take a look at the code. All right, so this is the structure of the framework. We have two very important directories here. We have the source directory, where we have the Illuminate package, and we have the tasks directory. Let's start with the source directory. Everything else is the standard PHP application. So you have a composer.json file, you have Docker for tasks, you have PHP unit for tasks as well, PHP stand for static analysis, etc. Inside source, we're going to find all of the different components that Laravel ships. This makes it very, very easy to find what you're looking for. Do you want to check something that relates to cache? Well, you can look inside the cache component. Do you want to look into something that refers to events? You can go into the events components. It's very, very well organized. So for example, I am doing some work on Eloquent. I know that Eloquent is within the database component. So I can go into database and then voila, we have an Eloquent directory and everything related to Eloquent is here. So as you can see, we have a context and a subcontext. The context is database, so everything related to the database component lives here, but Eloquent is a subcontext. Database does not depend on Eloquent, but Eloquent does depend on database. So it is inside database. It is a subcontext of database. So as you can see, we have one directory for each component. We do have a special component, and that's the foundation component. The foundation component is used by the Laravel full stack framework, that is Laravel, to basically boot the framework in its entirety. So if we go, for example, into support, we're going to have our service providers. If we go into application, you can see that it extends the container. So the container is part of the container component, and application is a part of the foundation component. And as you can see, it extends the container. So it uses other pieces of the framework. The foundation component is meant to be used by the Laravel framework, the Laravel full stack framework, what we use daily. If you're using Laravel or if you're using some specific Laravel components in your application and that's not a Laravel application, you're probably not using this. Another special component is the contracts component. And this basically, whoops, not this one, it basically holds interfaces. So if we go, for example, into events, we can see interfaces related to the events component. For example, the dispatcher. If we look which classes use this, we have the actual real dispatcher, we have the node dispatcher if you don't want to dispatch anything, and we have event fake if you're testing your application. This is really important. Laravel relies a lot in the service container, and it also relies a lot in interfaces. So most of the components in general, most of everything really is bound to interfaces. For example, let's go into database capsule manager. And as you can see, we have a method called setEventDispatcher. And as you can see, we expect a contract. We did not expect a concrete implementation. So this happens throughout the entire framework. It always expects an interface. Therefore, if you want to switch this implementation within your application, you can create a new class that implements dispatcher, for example, and do your own thing. And the framework is going to respect that as long as the contract is respected. It does take a while to get used to this structure, and you have to play with it a little bit to understand where things are. But in general, it is pretty organized. There's a lot of effort to ensure that these components are not tightly coupled to others. So for example, let's go into the cache component. And if we go into composer.json, we can see that it only requires the components it really needs. You can see that not even Redis is required here, even though Redis is a separate component right here. Therefore, you can use the cache component without utilizing the Redis component. Of course, if you want to use the Redis cache driver, you're going to need the Redis component, but it is not enforced. It is not going to be downloaded with the cache component by default. Of course, if you're using the Laravel framework, the full stack framework, you're going to have all of the components downloaded. So if we go, for example, let's go into cache, and then let's go into Redis store. Actually, let's go into array store first. As you can see, it extends a taggable store, and a taggable store implements a cache store, which is within the contracts component. The same happens with the lock provider. If it can provide locks, it implements the lock provider. And if we check all the classes that implement that, we have different cache drivers. We have Dynamo, we have Redis, we have Memcached, etc. So if you want to add a new lock provider to your application, you can just create a class and implement this interface. And then, of course, bind it to the container. The same happens within the Redis store. It is also a cache driver, so it also extends a taggable store, which implements store. So by definition, Redis store has to implement that interface. So to sum it up, each one of these directories represents a component, and we have two special components here. The first one is the contracts component, which is responsible for holding contracts for every other component. And the second one is the foundation component, which is meant to be used within the default Laravel full stack framework. These components do talk to each other, but again, coupling is something that's taken in mind, so they're not tightly coupled to one another, but the code will check, for example, if a certain component is bound, if it exists in the code. A good example of that is event dispatching. If we go into the events component, and then let's go into the dispatcher class, you can see that we have a resolve transaction manager class, and that refers to database transactions. We had a recent feature added to Laravel, which is a dispatch after commit interface. And what this does is if you have an event being dispatched within a database transaction, it will only get dispatched after the database transaction is committed. That does imply that event dispatching is now coupled to database transactions. And when you pull the events package, you're not pulling the database package. We can see this right here. We don't have database here. So what the framework does is it checks if a transaction manager exists at execution time. If we search for this, let's do this. There we go. We have an if block. So if it implements the should dispatch after commit interface, and if we have a transaction manager, then we want to use this functionality. If we do not, we don't want to use it. It doesn't make sense to listen to database transactions if we don't have the database package because it won't work. Okay, cool. So we already know how the components work. Another very important piece of the internals are the tests. This is a really big framework, and we need to ensure things are working. So tests kind of follow the same pattern. You have a directory for each component. So if you want to check the tests for the events component, you go into tests and then events. Now, the tests themselves do not necessarily follow the same name as the file being tested. For example, if we go into database, you can see that we don't have a file called database eloquent belongs to many. We have database eloquent. We have the eloquent component. So if you have lots of functionality and you want to have specific tests for those, it will usually be split amongst different files that test a specific behavior. For example, those files only test belongs to many. This file only test belongs to, etc., etc., etc. So it doesn't necessarily follow the name of the file plus test. Another difference is all of those components are unit tests, and we have a special directory for integration tests, which is, yes, you guessed it right, the integration directory. The major difference between those is those unit tests, they extend the PHP unit framework class. So let's look at them. As you can see, they extend the PHP test case, and the integration tests extend the orchestral test case, which is another library that we're going to talk about in the future. But again, the big difference is in those tests, you have to use mocks, for example. You cannot put the application, you cannot talk to database, whereas within the integration tests, you can actually boot the application, you can talk to database, you can run queries, you can dispatch events, all of that. For example, this is a task that I worked on recently, the should dispatch after commit task. And as you can see, we're actually dispatching events. We're talking to the framework, and then we're doing assertions. We're actually calling database transactions. We're doing all of that. And this is because we are extending a different task case. And in this scenario, we are actually booting the application. So we have access to that functionality. In the unit test, we don't have that because we are not actually booting the application. So as you can see, we just instantiate specific classes, and we also rely a lot on mocks to assert that certain things have been called. It's pretty simple to run the test. You just have to call PHP unit as usual. So for example, if we want to run the database tasks, we can call tasks database. And as they are unit tests, they're going to run quite quickly. And this is failing because it's something I'm working on. Now, if we want to test the integration test for the database component, we can run tests, integration, database. Those tests are slower because we're putting the framework, we are talking to a database, yada, yada, yada. But you can also notice that we have fewer of them. Exactly because of that. They're more expensive, and they also test more context. So we need fewer of them. And then we also have the types folder, which is used by PHP Stan to run static analysis. And we're not going to cover this today. And yeah, I think that's pretty much all for this video. It's long enough. There's a lot to talk about when it comes to Laravel Core. And if you guys are interested in this, I can go a little bit further on the next lessons. Maybe work on a feature that relates to the Laravel Core. Now let me fix this. or maybe build a new Laravel application and show you guys how you can find things. We know that everything starts at that index file. We know that we build the kernel. We know that we create a request object. Where do we go from there? So that's how I like to explore things. That's how I like to begin to understand how things work behind the scenes. I just keep clicking and seeing where it leads me to. And very quickly, you start to kind of understand how the framework works. I'm definitely not a Laravel Core expert, but I know where things are at. And if I happen to land on a nasty bug or something that's not well documented, I know where to look for things. And I think this is a very, very valuable skill. So if you guys enjoyed this kind of video, we can definitely go more in depth and look into maybe have a series for each Laravel core component. I think that would be pretty cool. So let me know what you think and let me know if this video was helpful. I'll see you guys on the next video. Bye-bye.